Okay, so today we're going to talk about mutations. So a mutation is simply a change in the sequence of DNA. So a mutation is a change, and we are changing the DNA sequence. So this ultimately leads to genetic variation. And this is going to come into play next week when we talk about meiosis, okay? Genetic variation. So when we're talking about variation, we're talking about variety, okay? So if you look up here, this just gives us a straightforward mutation. So you look at this sequence of DNA, and if you were to look at the sequence of DNA below it, what do you see that's different? Okay, so up here it's a what? And down here it's a C. Okay, so that shows us that there is some type of mutation, and in this case, it's called a point mutation. We're going to talk about a couple different types of mutations. So the first one we're going to talk about is substitution, and substitution is exactly what it says that it is. We're substituting a letter, so we're swapping out one letter for another letter. Okay, so one base is swapped out for another. So if you were to look at this top sequence of DNA and compare it to the bottom sequence, okay, you are going to notice that there is a difference. What's the difference? Okay, so the C down here is a, okay, so that tells us that there is a mutation. In this case, it's substitution because if you were to look at the rest of the bases, nothing else has changed. Everything else stays the same. It's just that one letter that is different. So if you are ever asked a question, okay, for example, how does the substitution affect the overall amino acid sequence? You would say that it changes just that one amino acid. Because if you were to then transcribe this and translate it, how many amino acids changed? Only one. And it's just that one where the substitution took place. All right, the next one is insertion. Once again, is what it says it is. So an insertion is when an extra base pair is added in a new place in the DNA, okay? So if you look at the top sequence versus the bottom sequence and we compare these, you will notice there's an extra C because we inserted a C at the bottom. So now, if you were asked a question, how does an insertion affect the overall amino acid sequence, you would tell me that it affects everything after the insertion, okay? Because if you were to compare the top, so we transcribe, translate, how many amino acids are different now? 2, okay? The reason being is because everything shifted to the right. Does everybody see that? Everything shifted right. So anything after that insertion is going to change because the sequence of bases for that specific codon is now changed. Everybody follow?
So where did the other C go?
This is the inserted one. This is the normal one. This is just the normal DNA.
Where's that last C go to? From the top and in, where does that go?
It would go to the one after, if this were to continue.
At this time, sophomore, last name G through Z. Please go to the Osborne lobby for pictures. Sophomores, last name G through Z.
What if it doesn't
So if there was a continuation of a specific protein, if this chain, this sequence kept going, that C would just start the next codon, okay? If not, then that's the end. Remember, we talked about stop and start codons yesterday,
Yes.
okay? All right, next one is deletion, is what it says it is. So now instead of subbing, inserting, we're deleting. So base pairs in this sequence are now either lost or deleted. So if you compare the top sequence to the bottom sequence, okay, we took out a what? We took out the A. So now instead of insertion and everything shifting to the right, we're shifting to the left, okay? So now all of these bases are shifting to the left. So in this case, okay, how does a deletion affect the overall amino acid sequence? Anything after the deletion, just like the insertion, is going to change, okay? So in this case, how many changed? How many amino acids? 3, okay? So in substitution, at the end of the day, you're only gonna have one amino acid that changes because you're just swapping letters, okay? For addition or insertion, deletion, you are going to have a change from the point of insertion or deletion and everything after that. So substitution, just that one amino acid. But insertion and deletion, it's going to be from wherever the point of insertion or deletion was and after. Does that make sense?
Yeah, so insertion. Alright, so substitution only affects one while insertion and deletion affect everything else. Insertion and deletion.
Yes, sir. Okay, so insertions and deletions are known as frame shift mutations. And the reason is because wherever that insertion or deletion happened, everything after is changing. So we are shifting all of those frames, okay? So because DNA is read in a 3-base sequence known as a codon, okay, we are calling these a reading frame. And therefore, at whatever point there was an insertion or deletion, that frame is now going to shift. So substitution is just substitution. One change, that's it. Insertion and deletion, they are frame shift because we are shifting everything from that point of insertion or deletion after. So a real world example is cystic fibrosis, okay? This is usually an inherited condition and it affects the cells that produce mucus, sweat, and digestive juices. So these secreted fluids are normally thin and slippery, but in somebody who has cystic fibrosis, there's a defective gene that causes this secretions to actually become thick and sticky. So it makes it hard for them to breathe, okay? So instead of acting as a lubricant, the secretions plug up tubes, ducts, and passageways, especially in the lungs, okay? This is most common in white people, but it also occurs in Hispanics, African Americans, and some Native Americans.
Last name A through F. Please go to the auditorium lobby for pictures. Freshman, last name A through F. This is also a great time for teachers who have not had their pictures made together.
So it is typically rare in people of Asian and Middle Eastern origin, okay? So another example is sickle cell, okay? This is the result of one nucleotide substitution. The previous one was a deletion. So this occurs in the hemoglobin gene, so normal blood cell, sickle cell, okay? So this changes the shape of the normal blood cells, and instead of being a little more circular, they look more like a crescent moon. So they are easier to get stuck and block the blood vessels. So therefore, it stops the flow of oxygen throughout the body. Normal, sickle. Okay? So these are just two examples of real world examples, okay? You will see these in your assignment for today. So let's sum up what we did today. What kind of mutation happened in each of the following? So if this top one is our original DNA sequence, I want you to tell me what mutation happened. So we've got to compare the top sequence to the following numbers. The first one is substitution. What we swap? The A and the G, okay?
It's substitution.
Number 2,
Yeah, he said.
deletion. What we delete?
Oh, wait. It was C.
Yes, okay, so make sure you look at these and compare them. In your assignment, I have them kind of on top of one another for you to be able to see it a little closer, okay? The last one, okay, what did we insert?
Wait, no. It was the.
We inserted a T, okay? So substitution, deletion, and insertion. So which of these would be considered frame shift?
Second and third
Because those are,
frame shift ones.
what are they?
They affect the whole thing.
Okay, so insertion and deletion are our frame shift ones, so 2 and 3, and they are what affect everything from that point forward. Okay?